Hi, I'm Adam Hand at the University of Nevada, and I'm going to talk about resource responsible use of high RAP up to 50% asphalt mixtures. This was developed with myself and Tim Aschenbrenner of FHWA, and it was developed under a cooperative agreement. This work was conducted under a cooperative agreement with the Federal Highway Administration. It's all about implementation. And UNR is the prime contractor, and ARA and Paragon Technical Services are our partners on the project. I'll give you a moment to read the disclaimer on the screen. So this work that we're presenting today is one of about 15 different tasks we have ongoing. This task is associated with the topic of high reclaimed asphalt pavement mixtures, and the reason I wanted to stop on this slide was to highlight the title of the tech brief that is associated with this webinar presentation. At the URL on the bottom of the screen, you can find the tech brief, and the document is FHWA HIF 22-003. Our target audience today is, and with all of these implementation focused webinars that we're doing in this series, is really on state DOTs, asphalt contractors and producers, as well as the engineering community that works both for the DOTs as well as contractors, and of course academics. The tech brief is 16 pages, and the outline is summarized here. We're going to go through each of these sections, but in summary, we're basically going to give you some background about how we went about developing the tech brief, and then the observations that we took away from the development, and then we'll sort of wrap things up with a summary. So in terms of background, there's a long history of using RAP here in the United States. It goes back to the oil embargo of the 70s. All states allow the use of RAP, and in 2008 we saw a significant peak in asphalt binder price, and that led to an interest to increase the amount of RAP that we were using in our mixtures. And shortly thereafter, 2011, and then again in 2013, a couple of key reports that came out, and you can find them in the references in the technical brief. One was by FHWA and the other was an NCHRP report, but both of them basically said that you could successfully use RAP and get similar performance to virgin mixtures with RAP up to about 30%. It wasn't really high levels of RAP. In 2014, the industry began we began to recognize that we're having some stiffness issues with our mixtures and getting some cracking that was really going to be a long-term durability problem. Folks began to do different things to see how they could succeed while using high doses of RAP, and the reason for that is with high doses, there's some really positive benefits from a sustainability perspective, not only in cost but environmental benefits, things like conservation of natural resources and reduction of greenhouse gases, and of course there are societal benefits. So our objective in this effort was to identify states that were using high doses of RAP up to 50% and visit with them to summarize the positive practices they were using and the lessons that they had learned, and then put together the tech brief that we did, a full report which is a summary of all of the individual state reports. There were 6 of them. This PowerPoint that we're using, and then present this webinar and future webinars if other folks would like it. The questions posed here: why responsibly use high RAP? Well, obviously, again, I talked a minute ago about the very positive environmental impacts on the conservation of natural resources and reduction of greenhouse gas emissions. And of course, cost. You can't just look at initial cost. You have to look at life cycle cost. So we want to make sure we get equal or better performance over the entire life of the life cycle of the pavement. And that's the goal, regardless of whether you're a state DOT or you're a producer. We want good performing mixes. Now, a little bit of background: the NAPA, National Asphalt Pavement Association, does an annual survey on recycled materials and warm mix asphalt use. The most recent version was just published a few weeks ago, and you can find the publication at this link in the lower left corner. And what this slide shows is that we produce around 400 million tons of hot mix annually in this country. We're 2019 we're at 422,000. 2020 408, and we'll probably be a little more than that in 2021. And I'm not going to go through all the data in this slide, but this shows the amount of tons of RAP that are basically generated and accepted. And the reality is about 93% of those go right back into hot mix asphalt. The others go into things like cold mix, recycled aggregates, etc. In 2020 alone, it's estimated that about 4.4 million tons of asphalt binder were saved by recycling. Asphalt pavement, 82 million tons of aggregate were saved, in a cost savings of about $3 million was realized. The slide on the picture on the left here, this shows RAP tonnage versus time, and this is over a 11-year period. And what we see here is that in terms of tonnage, most of the RAP or higher tonnage of RAP typically goes into DOT mixes until just very recently. Now, if we go to the slide on the right, the figure on the right, if we look at percent RAP utilization, we see on average, regardless of whether it's going to DOTs, other agencies, or commercial and residential applications, we've been averaging around 21% RAP in hot mix nationally for several years. But the commercial mixes have a little bit higher average than the DOTs, which are the DOTs are again here in the blue, so are right around 20 to 21%. This slide shows trends in allowable RAP percentages, and what we've seen in the last 11 years is a decrease in the number of agencies, DOTs, that allow between 0 and 9 or 10 and 14% RAP. So this blue and gold has dropped, and there's been an increase. You notice that this green here, there's been a pretty significant increase in the amount of agencies that allow between 20 and 29%. This slide is really encouraging because it illustrates the positive impacts of recycling from a greenhouse gas emission perspective. The blue bars are annual savings or reductions, I should say savings, annual reductions in millions of metric tons of CO2 equivalent, so greenhouse gas emissions, and we see a positive trend from 2009 to 2020. So we went from about 1.5 million metric tons to in 2009 to 2.3 million metric tons of greenhouse gas emissions in reductions in that 11-year period. Now in the background you see the yellow, and the yellow is a cumulative savings in emissions or reduction in emissions, and again over that same 11-year time period. It's pretty cool. The reduction in emissions due to using RAP and hot mix asphalt is almost 24 million metric tons over that time period. This slide shows warm mix use, and it was introduced in the late 2008-2009. The use of it increased significantly, and this is a plot in terms of tonnage. And then it sort of flattened out. And in 2017, though, the use began to increase, and the use of warm mix from 19 to 20, there was a pretty significant increase. And again, that was mostly in DOT mixes. So this is another encouraging trend from an environmental or sustainability perspective. This slide shows that early on, warm mix was primarily made by foaming with water, and about 10 to 15% chemicals were used. And today, primarily chemicals are used, or not primarily chemicals, just water and chemicals are used, and they're about a 50-50 split. Now, I want to thank the states that participated in our virtual visits. So we visited 6 states. They're Florida, Nebraska, New Jersey, South Carolina, Washington, and Wisconsin. And we didn't just pick 6 states out of our hat. We did a little bit of homework to try to make sure we found states that were truly using high percentages of RAP. And Florida was selected because they have an unlimited RAP use for some mixes. So in other words, you can put as much as you want in, depending on where they're going in the payment structure. Nebraska averages 39% RAP in their mixtures, or has for at least the last 6 years. New Jersey has a high RAP specification, which is unique because it has a minimum RAP requirement depending on the location in the payment structure. And New Jersey is using a balanced mix design approach. South Carolina uses 25 to 35% RAP. Washington State DOT allows up to 40% RBR, so you could, if it's all RAP, it could actually be over 40%. And they also are using a BMD approach. Wisconsin DOT boasts that over 95% of the hot mix that's produced for the DOT contains RAP, and there's up to 40% RAP in some mixes. So before we get into sort of the nuts and bolts of things, there were 2 things that were done by some states that were really positive, and one was sort of quantifying and communicating the benefits of recycling, and the other was measuring performance and reporting that. So we'll start with Nebraska DOT, and there's a link on this page here. And that's a link to a Nebraska annual report. And that annual report includes recycling goals, the amount that was recycled in the previous year, and the cost savings associated with that material that was recycled. Nebraska also has a special provision that incentivizes contractors to recycle because they get to share in the cost savings depending on where the RAP comes from, up to 50%. They also have what they call post-consumer labelings, and then on the plan sets you have this image here, and this image shows the raw material that's needed in terms of tonnage. How much is going to be replaced with post-consumer recycled materials, and what the percentage is. So 35% is going to be in this example, and the estimated value of that recycling. It's really cool. Every plan set has that, and Nebraska's estimated that since 2008 they've saved about 9 million tons of aggregate, almost 500,000 tons of asphalt binder, and have cost savings of about $408 million. The South Carolina DOT also has gone through the process of estimating the cost savings from using RAP. They did that as a percent of mix cost paid. And over a 5-year period from 2008 to 2016, they saw a range of 9 to 16%, and that they estimated the actual dollar savings associated with that to be about almost $91 million. Now this slide is a performance estimate, or really a comparison of high RAP and no RAP mixes. This was done by Florida DOT. It was published in TRB, Transportation Research Record, I should say, in 2012. And again, the reference for this you can find in the tech brief. And what the slide shows is these are different projects with 30% RAP, 35, 40, 45, and 50, and then 0% RAP. These are all intermediate coarse mixes, and the y-axis is performance, and it's really as a function of truck traffic and age, and the age is the age at which the pavement was resurfaced. And so we see here that as RAP increases from 30 to 50%, we get a slight decrease in overall performance of about probably 6%, 7% in here. However, on average, all of the wrap mixes outperform the average of the virgin mixes. So that's very. Now, Nebraska uses a condition rating that they call the Nebraska Serviceability Index, and it's got a scale of 0 to 100, and they consider a score of 70 to be good. And their goal for their overall system is to have between 80 and 85% of the highway system in a good condition. And the plot on the right shows that the interstate system is always, or as long as they've been tracking it, is over that goal of 80 to 85%. And from about 2015 to present, the goal of 80 to 85% has been reached for the total highway system. So that includes the interstate, non-interstate. What's really most interesting about this is that they implemented their high wrap spec in 2013, and the overall performance of the system has improved significantly. Washington State DOT has looked at the performance of its mixes twice. In the mid 80s, they looked at the comparison of virgin mixes and wrap mixes, and came to the conclusion that they were both offering equally promising performance. And then in 2017, they took a deep dive into their pavement management system data, and they looked at individual as well as composite performance factors, and then compared those for what they call high wrap. So basically, Washington has two categories, which is no to low wrap, which is 0 to 20%, and that's really binder replacement, and then greater than 20% binder replacement, which up to 40% binder replacement. So they have sort of low and high. The statistical analysis they performed revealed that they couldn't find a statistical difference in the two categories of mixes, low and high recycle. And Washington allows RAS in their mixes also. They did note that some of the high wrap mixes were relatively young compared to some of the virgin or low wrap mixes that were considered in the study. So what did these states do to succeed? Well, there's a whole list of items here, and we're going to go through each one of these individually. So this is a summary table. We won't go through the summary table, but I'll just suggest that you note the things that are highlighted in red with in bold X's, because those are items that many of the states were using. So if we start with the recycled material criteria, that's a criteria either by weight or by RVR. We sort of have two camps. The states that do not use RAS, zero RAS, seem to be using allowable percent RAM, when that's reclaimed asphalt materials, which would include RAP and RAS, by weight. Where those that are using RAS, right, allow RAS, are using RBR and for their criteria, and additionally several are using fractionation. Now, as far as rationale for location in the mix is in the pavement structure, different states did different things, right? So it's really it's part of its location, and then part of it is there could be traffic, there's lots of things that could be used. And what this slide, I'm not going to go through the nuts and bolts of this slide, but I'll just at the state level say that Florida considers mixed type location, binder type, and geographic location. And Nebraska DOT uses mixed type and location. New Jersey DOT uses mixed type and location. South Carolina DOT uses mixed type location and classification or traffic. Wisconsin DOT uses location, mixed type, traffic, RAM type, and wrap fractionation. And then Washington State DOT uses just mixed type. And as an example of some of the detail you'll find in the tech brief, Florida DOT allows unlimited wrap in intermediate and base mixes if the binder that's being used in the mix is a neat binder. 20% wrap can be used in dense graded friction courses, with granite aggregates and all intermediate mixtures that contain PG 7622. And then in southern Florida, they have these limestone, and it's not as ideal as the granitic materials they use in the northern part of the state. And in that area, you cannot use wrap in open graded friction courses, high polymer mixes, or dense graded friction courses. So South Carolina did a really good job of putting together a mix type selection guide. They identify the course that a mix would be going in. So we've got surface, intermediate, base, and there's some specialty mixes. And then within each course, so surface mixes, for example, they have types A, B, C, D, etc. And if you look at this closely, what you'll notice that the A's are the sort of the high-end mixes, so they're the high traffic levels, interstates, for example. And then as you work your way down to the B's and the C's and the D's, and even as far as E's, you're going to lower and lower traffic categories. This mix selection guide also has some really good comments, so I think it's a great tool because to help. I think sometimes we get siloed. We have mix designers in one part of one building in the DOT campus, and maybe the materials division in another campus, and so on and so forth, and they don't necessarily always talk. I think it's a great tool to make sure that the right mixes are being used in the right locations. And to go along with this, they have a table that indicates how much recycled materials can be used in each of those mix types. And what you'll note one thing you'll note here is that there are both non-fractionated and fractionated wrap. And with fractionated wrap, the contractor is allowed to use between 5 and 10% more wrap than with non-fractionated wrap. For quite some time, agencies have been using softer binders when they use wrap, and kind of like the criteria for the amount. We have had two schools with the 6 states. One is those agencies that are dropping PG grades, so they're bumping down, and that would be Florida, Nebraska, and New Jersey, and then Wisconsin and Washington DOT. They require that the blended binder, which would be your virgin binder, your wrap binder, and if you have a recycling agent or something, that blend be the PG grade for the given location that the mix is going to be used in. Additional asphalt content is a big deal. Several states were taking different measures to try to get additional asphalt content into their mixtures. One common thing was using a reduced number of gyrations, so maybe going from 100 gyrations at a given traffic level down to say 75. Another is regressed air voids. So in other words, selecting optimum asphalt contents at an air void level below 4%. So Nebraska, as an example, goes down as low as at 1.5% air void. So that's going to be a real high mix, I think, real high wrap content mix, and probably on a shoulder. We also saw that several of the states were using VMA as a tool, so having a VMA criteria that was greater than the minimum in the M323. And then finally, some states were using the bulk specific gravity of the wrap aggregates. We all know that if we use our effective specific gravity, we overestimate our VMA, and that's a problem when you get to high wrap mixes. So Wisconsin DOT was using reduced gyrations, regressed air voids, increased VMA, and wrap bulk specific gravities. So that's again a good example of some best practices there. South Carolina DOT is using something that they call the corrective optimum asphalt content, and what they do is they basically are suggesting that only about 75% of the binder in the wrap is available. So what you do is you do an asphalt content, you come up with your optimum, and then you add, for whatever percentage of the total binder is in that optimum, you add an additional 25% of whatever the contribution is from the recycled materials. So in this example, you get an optimum of 5%, and then the aged binder, or the binder in the wrap, was 1.56% of the total. So you multiply that by 0.25 and you add it to the 5% that you had for your total, and you end up with a 5.4% optimum asphalt content. One of the things that several of the states did was allow the use of additives for making high wrap mixes. Warm mix asphalt was allowed by all states as long as it was chemical at the contractor's option. 4 states allowed the use of foamed asphalt for warm mix. And then as far as liquid anti-strips go, the 5 of the 6 DOTs either allowed or required them. And Wisconsin DOT also included the use of hydrated lime. And for recycling agents, New Jersey and Washington State DOTs allow recycling agents at the contractor's option. And in both cases, it's the need to get the grade of the blended binder to the grade that's required for the particular climate. And then the Florida Department of Transportation, they want to limit the amount of reob that can be used, and they've got a provision to do that, which is a combination of a delta TC waste oil provision and a limit on the amount of reob. When it comes to mixed performance tests, 3 states are using performance tests currently. New Jersey is using the APA and Texas overlay, and South Carolina is using the APA. The Washington State DOT is using the Hamburg wheel track test in the the indirect tensile strength test. And actually, WashDOT has been doing that since, I think, about 2013 when they implemented their high wrap spec. All the states are doing some form of research, and when it comes to performance testing, and the tests of interest that were identified by the states were listed in this bottom row here, and it's pretty clear that ideal CT and Hamburg wheel track tests are the most common among the states that at least that we interviewed. As far as processing and handling goes, one thing that was pretty common was requiring QC plans, and that might be for wrap specifically, or that wrap be included in project QC plans. The contractors, so we asked the DOTs if we could schedule interviews with contractors, and sometimes those might have been like organized through a state pavement association. There might be multiple contractors in the interview, and we had a standard question set, and we asked them, what they thought they were doing that was helping them be successful with high wrap use. And the most common responses were, one was verifying the percent wrap, so not only the percent of wrap that's going in the plant, but the amount of binder in the wrap, and having good control of that, and then controlling dust. As we increase the amount of wrap that we use, we're increasing 200s, and the amount of material past the number 200, so we may have to reject fines. Oh, excuse me. So contractors also said that getting representative samples was really important. And in 2 states, contractors indicated that they were using cold milling machines, regular, full-size cold milling machines to collect large samples of wrap, so that they had good ideas of what they were going to be using when they went into production. They all talked about having the right hardware at the plant. In other words, right equipment that was needed at the plant to successfully use a wrap. Moisture content or managing moisture was another topic that came up frequently. Wrap has a tendency to carry high percentages of moisture, so obviously it's important. And then again, controlling fines, and then performing process control. So that's testing and inspection that's beyond what's required in terms of QC. And it's really, these last three bullets are really interesting because these came from the contractors, right? And the one is a state DOT requirement that each asphalt plant has an on-site QC lab. Another was having a full-time state inspector at the asphalt plant, again, coming from a contract. And then finally, that state DOT PWL specifications incentivize contractors to produce consistent RAP, and that led to adequate contractor process control and quality control, because they want to succeed. They want to be able to get full payment for the product that they place, if not bonus. Now, so that's sort of the observations. Now we're going to go into the sort of the from an implementation perspective, what agencies might want to consider in terms of programmatically, mixed design acceptance, production, and then quality. From a programmatic perspective, again, we saw that successful states were using some selection criteria for mixed type and allowable percentage of RAP, right? Having strong QA programs, reporting annual RAP use, incentivizing contractors to use RAP. Again, Nebraska had that interesting special provision, and then another incentive would be paying for asphalt as a separate item. Tracking and reporting cost savings associated with the use of RAP, and then monitoring RAP performance and RAP mix performance, and then looking at that performance as a function of time and making revisions to optimize the performance of mixes. From a mix design perspective, considerations would be, again, our criteria by weight or RBR, using softer binders, increasing asphalt binder content, and there's lots of different techniques the different agencies were using, using recycling agents, characterizing RAP, having a good understanding of the RAP that's being used. So in other words, having a specification that encourages the contractors to do that. Using the bulk specific gravity of the RAP aggregates rather than GSE to calculate VMA. Again, if you're using 10% RAP, it's not a big deal, but when you get up to about 30%, you can begin to see some pretty significant differences in actual VMA and indicated VMA from using GSE. Using mixed performance tests, that's the path of the balanced mix design. And then again, Florida was using some binder performance tests to limit the use of reop. From an acceptance perspective, the PWL specification, right? We heard not only from the states being happy with it, but also the contractors saying that it was part of the reason why they were successful. Using mixed performance tests, again, New Jersey and Washington are doing that, and then paying for asphalt as a separate item in both Nebraska and South Dakota. From a RAP production perspective, some states require dedicated stockpiles. So in other words, a contractor processes RAP and sort of sets it aside as a lot, and that material can be used in a given mix design, right? So the mix design will identify the lot of RAP, and only that RAP can be used in that mix. You can't supplement the piles. And then allowing fractionation was reported as a positive practice. From a QC perspective, having the quality control plans, whether it be specifically for RAP or RAP being included in a project QC plan, and then requiring plant control reports that indicate proportioning be printed or dumped to a data log or whatever on a given frequency, and then having a full-time inspector at the asphalt plant. We also asked the states, what they thought there were needs in terms of research and training, and Florida DOT indicated that there was a need for a high RAP mix design methodology for very, very low roads. New Jersey and WashDOT indicated that there was a need for additional recycling agent research. New Jersey identified alternative wrap uses, or the need for identifying alternative wrap uses because they use a lot of high performance thin surface courses rather than doing mill and fills. So they've got wrap on the ground that's not going back into surface mixes, and a lot of work is surface mix. South Carolina DOT believes there's research needed on top-down cracking with high wrap mixes. Wisconsin DOT believes that there's research needed to optimize recycled mixtures, materials use in asphalt, and they regularly have ongoing research on that topic. And then 3 states said that there was a need for training for staff and local agencies on successful use of high wrap. Alternative uses of wrap that were identified by the states are on this slide, and again, I'm not going to go through all of these, but to say that all the states use it in hot mix is an understatement, right? They're sort of super users, but they also many of the states find uses of it in base courses, borrow materials, etc. The other sort of category of uses that was identified was cold recycling techniques, whether it be cold in place recycling, full depth reclamation, or cold central plant recycling. And 2 states, South Carolina and Wisconsin, identified full depth reclamation as a real good use, and they're using quite a bit of it. So in summary, the use of wrap and asphalt mixtures can provide sustainable benefits from not only cost perspective but environmental and societal benefits. Improvements in materials mix design and processing and handling can lead to successful use of high wrap mixes. We've seen that. NAPA reports that about 20-21% wrap is typically used by state DOTs, but those that participated, 6 that participated in this process, are using basically 30 to 50%, and that's pretty darn good. That's really taking it to another level above the average state. The states indicated optimizing wrap for good performance can be accomplished through several things, and at a very high level, regular review of DOT specs, mix design procedures, and performance test methods, and then monitoring pavement performance and working with the collectively as a team, the agency and industry together to make improvements to specifications, and then reporting the benefits of wrap, whether it be cost savings, material use, total recycled materials used, materials that were conserved because they weren't mined or refined, as well as performance. And again, we can't forget the societal benefits are important. And with that, this slide has got the contact information for both Tim Ashenbrenner, my partner in developing this, and myself. So we've got our telephone numbers as well as our emails. And the link to the tech brief is in the uppermost part of the slide in blue there. With that, we thank you and appreciate you taking the time to watch this video.